Maybe we should move it closer and not zoom in so that it's picking up sound from him and not everybody else.
Or Steve could just be louder.
I could just repeat everything he says.
For the hearing impaired, say it louder.
Yeah, I feel like I was looking into lapels because I feel like that's how you're gonna get the best audio, but then we'd have to like sync it up and do a whole thing. So we'll try it. We'll see how it goes. Okay, is it recording?
Yes.
All right, cool. Thanks everybody for showing up. This is my/our talk because you'll see there's a lot of other people who contributed towards the end on crafting your digital playground, a Homelab journey. And continuing the theme of all of my talks so far, there's an AI generated image there for you about, I don't remember what the prompt was, something about a house and a server and a journey, and so it put it made a house into a server on a road, which represents the journey. I don't know.
That's a pretty cool computer case, though.
Yeah.
That has to be a pretty cool computer
That would be
case.
pretty cool. Okay, so what is a home lab? Really, like I think the most general definition is it's just a server, it's just a computer in your house. And you know, if you want to be like, oh, it's on all the time, or host services, or whatever, but like you don't have to be too prescriptive. It's just a computer in your house that you do stuff with. It could be as simple as a Raspberry Pi, which if you're not familiar with, they're like, well, they were $30. I don't know how much they are now. How much are they now? Does anybody know?
More than that.
$50. So you can get like a pretty cheap thing called a Raspberry Pi, and you can just hook it up to like a USB external drive. And in fact, someone's home lab that they show at the end is in fact just that, and it's perfect. Like it's the absolute perfect entry home lab server, and you can do a ton of stuff with that. Or you can go crazy like this guy on YouTube who has two dedicated rooms in his house. One has these 3 racks, 2 of which are like hard drives and networking equipment. He's got a mini split in there to cool the whole thing down. And then he has a whole other room that's just like power distribution and battery backup. Like, I don't know what this guy does. I don't know if he hosts stuff at his house or whatever, but he went way over the top. So why is a home lab? Basically, it's a place where you can learn and break things. So you get your little Raspberry Pi, you spin stuff up, you start poking around with things, you start editing config files, all of a sudden everything breaks. Fine, just wipe it, reinstall it from the ground up, and do it all over again. And it's just totally like consequence-free place to play around and try things out. So you can learn things like Linux, you can learn networking, you know, your home lab sort of extends beyond the server. It includes like your home network, so you can start playing around with all sorts of cool stuff like VLANs. There's a thing called Kubernetes, which if you go Google it if you want to learn about that. That's like a thing in my world is a lot of the engineers and like my colleagues, they like to spin up Kubernetes on their home lab. You can learn about security and ethical hacking. So if you maybe set up one Raspberry Pi and another Raspberry Pi and you like lock the one down and then you try and hack into it from the other one, but you're doing it all from within your home network, so it's totally kosher. You can do stuff like that. It's totally your sandbox to play around and do whatever you want. You can also run your own cloud services. So there's certain stuff that maybe you feel like, hey, I don't want big tech sniffing in my business, right? I don't want them scanning all of my photos to try and sell me ads. I don't want them, looking into all of my private communiques. And maybe there's stuff that you just don't even want on the internet, period. Doesn't matter who's hosting it. That would be stuff like tax document backups. But you still maybe want a digital backup of them. You can host that on a home lab. There's this really cool website called awesomeselfhosted.net. And it's really a GitHub repo with a bunch of text, but they rendered it out in this cool website. And you can see there's like all these categories on the side here, and they're all just different categories of software that you can host yourself. So there's like automation, which I bet Home Assistant's somewhere in there. There's like blogging platforms, there's calendars. I know Chad was asking about like, he wanted to be able to like rent out his apartment to friends. There's like a whole scheduling calendar thing in here. There's e-commerce, there's ebooks, databases, files, photos, media streaming, like password managers, a whole bunch of stuff in here that you can host on your own. So I recommend like, if you're like, oh man, I just want to, what do I host? I would just like peruse this and find something and try and run it locally. See if it's cool. Yeah, so some examples of like big text stuff that you can replace rather than Google Photos. You can use this thing called Image. I use that. Super good. I can give a demo from my phone after this. But it'll do like all the facial recognition stuff, so it'll find everyone's faces, and then you can just name one of the example faces and then say, show me all the pictures with Doug, and it'll just pull them all up. It'll also do machine learning stuff with like a vector database. So you can say, show me all, you can just say cables, and it'll show you all the photos of cables, which is really useful because I had a photo of my old Homelab from like 2020, and I just typed in cables, and it showed me all the random pictures of cables I have, and I found all the Homelab in it. You can replace Dropbox with this thing called SyncThing. That's like a peer-to-peer file syncing service. So I have that running on my Homelab, so I have at least one thing in the peer-to-peer network that's always up.
Does that integrate with Image?
Image has its own mobile app that can do backups for you. But there's no reason you couldn't, like, I don't know that you would want to do this, but you could just have like the image photo location inside of SyncThing, yeah. You can potentially get rid of Google Drive with Nextcloud. Nextcloud's like open source document management thing. I really like Tube Archivist. I use it as sort of my personal front end to YouTube because you can put in like, okay, I like these YouTubers, and you subscribe to them in Tube Archivist, and you just say go, and it downloads their entire catalog of videos. And you can set it up with sponsor blocks, so it'll remove all of the like in-video ads. It obviously removes the YouTube ads. And then there's no algorithm, right? Like who I subscribe to, that's the content I see when I open up Tube Archivist. So I don't have to deal with all of the like algorithm spam. And I can just like curate who I want to watch. And then if someone gets like a copyright strike or their channel gets taken down, you have all those videos saved locally. That's useful for channels like Nile Red or Cody's Lab, where they're doing like chemistry stuff, and like all of a sudden somebody's like, "No, they're making a bomb." Home Assistant is another thing you can host. So we use that here at the makerspace, right? If you try and use the bathroom in there, there's this little magnet with a sensor, and this communicates on a wireless protocol called Zigbee. And there's a server over there in the corner that has an antenna that talks to Zigbee, and Home Assistant's running on that server. So whenever this magnet passes by the sensor, it sends a signal to the Home Assistant, and Home Assistant goes, somebody moved the light. And so it then sends a signal to the Zigbee outlet to say turn on the light. And then after 20, 30 minutes, it sends another signal to turn off the light. So that's how that light works. You can do stuff with like in your bathroom, you can put a little humidity sensor, and then that talks to Zigbee, and you can replace the switch for your fan with a Zigbee switch, so that you can still turn it on and off manually, but it can also turn on and off through Zigbee. And you can just have Home Assistant monitoring the humidity. When it hits a certain threshold, you turn the exhaust fan on, and then it'll stay on until it goes below whatever threshold you set. Which is really nice because like you walk in, you shower, and then you leave, and you turn everything off, but there's probably still a lot of humidity in the air. This was one I saw on Hacker News recently. Someone actually in Ukraine subscribes to a bunch of Telegram channels, and those channels send out information about like bombers that have just taken off in Russia, or missile launches that were detected in Russia. And there's like an hour between when they detect something taking off or being launched and when the strike will actually happen in Ukraine. And where he lives, like the problem he has to face basically is like if he has his phone blow up for every message to that Telegram channel, he would never sleep. So he wants to filter for just the things that are going to impact his region, and things that like he wants them to notify him when like he should actually like leave, and not an hour ahead of time, so he can maximize the amount of sleep he gets. So I thought that was kind of cool. Another reason why you might want a Homelab is for data hoarding. So you can archive all the content you care about. So I already talked about YouTube channels. You could host a mirror of the Internet Archive, which is just like all of the legal, open, free information that exists on the internet, basically. You could host or mirror a copy of Wikipedia. You could also go and get all of the CDs, DVDs, and Blu-rays you own, and you could rip them all onto your hard drive, so you have like a digital copy of all of those. If you want more ideas of stuff you can do, check out Data Hoarder. They're more like their ethos is maybe a little more piratey than I would be willing to like advocate for in a public forum like this. But if you were of that ilk, there's a thing called Library Genesis you might want to look up. It's basically every digital ebook that's ever been put on the internet ever. You could post a copy of that. Okay, hopefully I've intrigued you a little bit into what a home lab is and why you might want to have one. How would you build one? What are the technical choices you would make when you're making a home lab? So, first decision you have to make is build versus buy. So you can just buy a pre-made home lab. You can do what I said earlier, which is just buy a Raspberry Pi, buy a USB drive, hook them up, you're done. That's like the absolute cheapest way to go. Simplest thing to do, you're like up and running in a day. The other thing you could do, which is going to be like a way smoother, cleaner experience because it won't require you to manage any software, is you could buy a Synology NAS. NAS is network attached storage, or a QNAP NAS. And these are basically like you put hard drives in these slots, you plug the power in, and plug an Ethernet cable in, and you're done. It's got all the software pre-installed, it's got an operating system. Synology and QNAP do all of that for you, and then installing services is like a click of a button. But if QNAP and Synology haven't packaged a particular service for you, then you're out of luck. So like, I don't know if they support image. I know they support things like Plex. So it's like super smooth experience, but I don't know how much freedom and flexibility you have.
Does it support your Coral thing?
The
Yes.
Synology?
Yeah.
Such a good question. I don't know. Such a good question. I would have to read up on it because you might actually be able to. I'll talk later about what containers are, but you may be able to like spin up arbitrary containers on that. And if it's Linux under the hood, you may be able to install the drivers for Coral. But if you start doing that, then you're sort of leaving the streamlinedness of it, right? It's like trying to root an Apple phone. Like, why would you do that? It's a walled garden. You want to stay within the walled garden. If you want the customized experience, go with like the Android kind of thing. So the other option is you can go build your own. This is a lot like building a gaming rig. Just you're focused more on your home lab, like data and like video processing, than you are gaming. So you can go out and buy all the custom components for yourself. There's going to be a recommendation later on to buy stuff from eBay. You can totally do that. That's totally valid. Probably will save you a ton of money. If you do this, you have total control and customizability, right? You can target whatever performance you want, whatever form factor you want. Maybe you want to go entirely fanless. Maybe you want to go super low energy. So it's like 10 watts when you plug the thing in and it costs basically nothing to run. There's a great website called PC Parts Picker. I use it for my gaming rigs and my servers. It's really great because you can say like, okay, I'm gonna go choose a CPU. So maybe you go to, that's my next thing. Maybe you go to CPU benchmark and you look at the benchmark performance per dollar of processors. You say, okay, this is the processor I want. And so you plug in that processor. Then when you go to choose a motherboard, it'll only show you motherboards that support that particular processor. It'll show you like, if you picked an Intel, the latest generation, it'll only show you sockets that support that latest generation of Intel. And then when you go to choose memory, it'll only show you memory that's compatible with that motherboard, so on and so forth. So it's great for like compatibility stuff. But my general recommendation is like start small. So if you've never run a home lab before, don't bother with this. Just go the Raspberry Pi route. It's gonna be super cheap, lets you get it in the ground floor, you can try some stuff and you'll grow into it, right? Like at some point you may max out the Raspberry Pi, and that's awesome. That means you're exploring and doing a lot of cool stuff, at which point maybe it's worth investing the money on building your own thing. So yeah, if you're gonna buy a CPU, if you're gonna do it yourself, my general recommendation is pick Intel just because a lot of services can take advantage of that hardware better. So if you look at Plex, and like things like Plex or Image or Frigate, which are doing video processing, image processing, they're all gonna be able to take advantage of the hardware acceleration that's in the Intel processor. Versus if you go AMD, it's gonna have to do just like the generic sort of operations, which are gonna be slower and use more power. For power usage, you want to look at what's called TDP there. So these range from 120 watts to 65 watts. And that's basically how much energy is the processor consuming and giving off in terms of heat. And so the higher your TDP, the more performance you're going to get, but the bigger your fan's going to be, the louder your server's going to be, right? So if you want to go for like a quiet, slimline thing, you want to be on the lower end of the TDP spectrum. For memory, do you plan on hosting a bunch of stuff? Do you plan on using what are virtual machines, which I'll talk about later what those are? If you're planning on hosting oodles and oodles of stuff, it's probably worth getting a lot of memory. And if you're building your own server, hopefully there's enough DIMMs slots that you can like fill 2 of them with what you think is the target, and then you'll have 2 more to spare if you ever want to expand. For disk, you want to think about like, what am I storing? Am I storing terabytes worth of downloaded videos? Am I storing tons of photos? Am I storing like 24/7 security cam footage for the past 5 years? Or am I just storing a couple of PDF documents? And then work back how much storage you think you need. And then we'll talk more about how you can add data protection by adding more hard drives. So make sure to factor that in. And then I recommend getting 2 different types of hard drives. Get a SSD or an NVMe drive. Those are solid state drives, which means that they're super fast, like really low latency, really good at random reads and accesses, and put your operating system on that. And then go buy a bunch of spinning drives and use those to store all of your media and stuff. So this will make your computer boot really fast, it'll make things run really fast, and then these are the cost-effective way to store lots of data. All right, any questions so far? All right, cool. For networking, definitely recommend hardwiring your Homelab if at all possible. So like figure out where your router is and figure out if you can either A, put your Homelab next to it, or can you somehow run an Ethernet cable from your router to your Homelab? Because if you're trying to do it wireless, like, you're just gonna have a bad time overall. And also your performance is gonna be cut in half, right? Because if you're uploading from your laptop to your Homelab and they're both on Wi-Fi, you're eating half the bandwidth from your laptop to the router and the other half is from the router to your Homelab. So you're immediately cutting your bandwidth in half. Yeah, and check to see, like, does your router support gigabit? Does your Homelab support gigabit? Like, try and get everything at the same technology level so you get the best speed possible. And then I'll talk a little bit more about port forwarding, but if you want to be able to access the stuff you run on your Homelab from outside your house, you'll have to be pretty familiar with your internet service provider's router. And I think this is the final piece of hardware. If you want, you can get a battery backup. So I had one of these. We demolished it here at the makerspace. It's really great for giving you the opportunity to do a clean shutdown during a power outage. It's not gonna weather a power outage for you. Like, you can't expect this thing to run your entire Homelab and your home network for 2 hours while the power company fixes your power. But it can keep things running for 15 minutes, right? And that'll give you time to go in and shut things down. You could even actually install a driver and connect it up via USB to your server so that when the power goes out, it actually sends the shutdown signal to your server and tells it to shut down so that all your data is safe. If you just run your modem and your router on it, I've actually gotten like half an hour out of it, which is kind of cool when your power goes out, but like it's just your street or whatever and the internet's still up. Oh yeah, so here's where like some fun comes in. Every computer on the network has a name. And you get to set that name, right? So here's your opportunity for some fun and some whimsy, right? Think of a scheme or a theme and just name all of your computers on your network based off that theme. Maybe it's things like fruits or mountains or countries. I name mine after micronations. Could be gems or Ninja Turtles or colors. If you want some ideas, I found this website called Naming Schemes, and it's just literally like every possible thing you could think of grouped. So like books of the Old Testament, stuff from Game of Thrones, actresses, actors, apples, archery, like pick your theme and it'll have options for you. And then this was Xavier actually, this was a pretty good request for comments. So a bunch of the internet and the protocols that the internet runs on are documented and like explained via things called RFCs, requests for comments. And so this one just walks you through like how to choose the name for your computer. So if you're trying to come up with some good names, maybe peruse that as well. Okay, so now we move into the realm of software. So like, what operating system are you gonna put on this? Obviously there's a huge bias here. I recommend Linux. If you wanna go the like raw Linux route, I recommend starting with Ubuntu and just look up LTS. That stands for long-term support. So LTS is sort of like Windows 10, Windows 11, like it's gonna last like 6-7 years. They're just gonna keep backporting all the security fixes and stuff to it. So you can install it once and it should last a good chunk of time. Debian is like what Ubuntu is built on top of, so you could also go that route if you wanted. You can also there's like whole subreddits on like Linux distros and distro hopping and like figuring out exactly which one you want. Like you can go that route if you want. That's totally, if you want to do that, go for it. I don't recommend starting out with something, actually just generally don't recommend something like Arch for your server. That's more of a ship of Theseus style distro where like anytime any one piece of software updates, it's immediately available for you to download and install. And that just is a little more chaotic than Ubuntu, where they make sure that everything's like super stable and you're not going to rock the boat. You can also go with network attached storage specific operating systems. So there's things like Proxmox, Unraid, TrueNAS These are all operating systems that are designed for you wanting to host a bunch of storage. They have like, they're Linux based, but their batteries included, so they usually install all the software you might need. They have like little GUIs in the browser, so you can just like click around and stuff. It's much simpler than trying to go all the way to the command line. But if you want like the real like hardcore nerd, you want like the nerd badge, you can try the command line route. And you can go Windows, but I just don't have any expertise with that. So maybe someone here does, that could be the next talk. Okay, so earlier I was talking about we can do a bunch of cool stuff with data protection if we have more hard drives. This is that section of the talk. So when you go in and like install Windows, you're probably setting it up with what's called NTFS. I actually don't have it here. If you're installing Linux, you're probably formatting your hard drive with ext4. If you're trying to do something like dual boot, then maybe you're putting exFAT on one of your drives. These are all just like languages that the operating system speaks when it's talking to your hard drive. It's just the way that data gets laid out on the hard drive. And these are all single drive file systems. So they're designed to be like put on one hard drive and that's it. If that hard drive dies, your data's gone. There are other file systems that are designed to run across multiple drives, like ZFS, ButterFS, there's a bunch more, you can Google around for them. But the idea is that these support a thing called RAID. And RAID's like this general idea, stands for redundant array of inexpensive disks. And the idea is like, hard drives can die at any point in time. We want to make our data resilient to hard drive failure. So the simplest way to do that is what's called RAID 1, where you have one hard drive. Actually, in this case, it's 8 hard drives, but you could also think of it as one hard drive, where we write all the data. And we write an exact copy of that data over here. So now if this hard drive dies, it's totally fine. That hard drive's still there, has a complete copy of the data. We can go out to Micro Center, buy another hard drive, slap it in, and the system will automatically copy from the still good hard drive to the new hard drive. Our data's saved. The problem with this is the overhead is 50%, right? Like if I have a terabyte hard drive in each one of these, I can only use a terabyte, even though I have 2 terabytes of capacity. So there's something that's a little more efficient, that's called RAID 3 and RAID 5, slight variations in the same theme, which is we write the data across these 3 drives, and we write a parity bit on this drive. So now you might ask, what the hell is parity? Can we turn the light on real quick?
Yeah.
This is the one part I wanted to do on the board. Okay, so let's say that's drive A, drive B, drive C, drive D, and this is the parity drive, right? So let's say our data, well, let's first say our parity scheme is, if we sum these numbers and they're even, we put a 0 for parity. If we sum these numbers and they're odd, we put a 1. That's our parity scheme. So 0 plus 0 plus 0 is 0, which is even, so we put a 0. If we do something like that, we sum these together, we get 1, which is odd, so that'll be 1. In this case, right, parity bit's going to be
0.
Yep. In that case?
1.
Yep. Okay. So now, what happens if I lose my parity drive? Well, all of my original data is still there, right? We don't have to do anything. I can just go out to Micro Center, buy a new hard drive, slap it in. We can redo the math we just did and rebuild the parity drive. Okay. But what happens if I lose this drive? Okay. Well, we can reconstruct this. Right, that was the original. I can say, okay, 0 plus 0, and the parity is 0. So 0 plus what plus 0 will equal 0. Well, that has to be 0. So that's how we reconstruct that. Okay, 0 plus 1 had to be odd, equals 1 or 3 right? It could be either one of those. Well, it can't be, if we add 1 there, right, then it ends up as 2, so it can't be that. So this also had to be 0. You can do the same thing here. These two sum to an even number, and this represents that the sum has to be even, so we know that doesn't change anything. And if this doesn't exist, then 1 plus 1 has to sum to an odd, so the only way you get odd from these two is to add a third one. Is that making sense so far? Yeah. So you can do the same exercise for A and C. You can lose any one of these 4 drives, and you can reconstruct the data from any of them using that parity bit. And the cool part is, you can flick the lights off again for me. Thank you very much. The cool part is, the overhead of this is only 25%, right? If each one of these is a terabyte, we get 3 terabytes worth of data and 1 terabyte of parity. So we've saved a lot of space. And then the only difference between grade 3 and grade 5 is if you have many, many drives. The parity gets striped across the drives rather than stored just on 1. And then you can go really crazy with it and do what's called RAID 6, which is the exact same as RAID 5, but you write 2 bits of parity. And so now, in this example, we're writing 3 bits of data and 2 bits of parity. And so you can survive 2 hard drive failures and still recover all of your data. So this is really important, like if you have tons and tons of data, if one of your hard drives fails, you pull it out, you put a new one in. In the process of reconstructing that hard drive, you put all of the existing hard drives under heavy strain. And so they're more likely to fail during that rebuild. And if any of them fail during the rebuild, you're hosed. So RAID 6 is really great because if one drive fails, you order one on Amazon or Micro Center, slap it in, it starts rebuilding. Under the pressure of rebuilding, another one fails, it's okay because you can survive 2 hard drive failures. So yeah, like ZFS also does a bunch of other cool stuff. It does the RAID, it does compression. There's a thing called bit rot, where like you can literally write data to a hard drive and just put it in a closet. And if you come back 10 years later, some of those bits will be flipped. It's just the nature of the medium, because you're dealing with magnetism and stuff. So what it'll do is it has all sorts of that sort of parity idea, but at the file system level on top of RAID. And so it can like do a whole pass over the data and say, oh, bits flipped, I can go correct those. So it's also supported by a bunch of companies. One of them I used to work at, so I have a lot of bias here, but definitely check out ZFS. It's cool. Okay, any questions about storage and RAID? Okay, cool. So now you want to go like run stuff. You can just do bare metal, right? This is like what we're all used to. You have your hardware, you install your operating system, and you install apps. Cool. That's like the cheapest, slimmest way to do it. You can do something different, which is called virtualization, where you run your host operating system, you install a hypervisor like VirtualBox or VMware, and then you run what are called virtual machines. And each one of these virtual machines will have their own copy of their own operating system, on which you can install an app. And so these 2 virtual machines are totally independent, and the stuff you do in this virtual machine can't affect this virtual machine and vice versa. And almost more importantly, nothing you do in this virtual machine can affect your host operating system. So it's just like total isolation. And this is what happens when you go and you rent a server from Amazon. Like you go on EC2 and you get a virtual machine from them. They have a hypervisor and they give you just a virtual machine, so you can't actually interact directly with the hardware. It has to go through that hypervisor. The problem here is, if you look at like all of this has to be in memory at once, we have 1, 2, 3 entire operating systems that all have to live in memory at the same time. That's going to be super heavy on your memory. So what you can do instead is you can do a thing called containerized. You can run containers. And the idea is you take advantage of some of the properties and like the isolation the operating system provides to lock down each one of these apps to their own little sandbox. And so now you can install a whole bunch of stuff in this container and it has no effect on these containers or your host operating system. So that's what I do. I run a bunch of containers on mine. And so like, maybe I'll skip this and this and basically say, if you do stuff with containers, all you have to do is just say Docker pool Redis, Docker pool image, Docker pool, like whatever the name of your service is, they probably have a thing up on Docker Hub, so it just pulls it right down and starts running it. And if you have a bunch of services you want to run, you can put them all in what's called a YAML file, Docker compose YAML file. You just say like, here's my image service, here's Plex, here's my torrenting thing, here's this, here's that. You just define all the services you want to run, and you just say Docker compose up. And it just spins them all up. And they're all independent. And you can even, because there's this virtualization, you can do stuff like on the host operating system, maybe stuff lives at /data, /homelabs, /image, or plex, or whatever. And you can mount each one of those directories into an entirely different location within the container. So this app might want its data to live at /Etsy /my-data, right? And you can say, like, you can do a rewriting where it's basically like, really it lives here, but I'm gonna make you think it lives somewhere else. And so now you can sort of contain all of your configuration into one place on the host. I guess another benefit of virtual machines is this whole thing ends up looking like a file on the host operating system. So to back up this whole system, you just copy the file. You can just back up that file. You can then delete, rewipe, reinstall, do whatever you want with the host operating system, copy that file back on and spin the virtual machine up like nothing happened. So that's a cool thing about virtual machines.
Can you do that with containers? Does it save it as a file that you can copy?
No. So it's really easy to like re-download a container, but that'll just have like the original stuff that was in there. You would have to mount your files that are on your host operating system into it. So what I typically do is, can we turn the lights on one more time?
Yeah.
Sorry. So like if this is my host, I may have like my RAID hard drives. They're mounted at like /data. And then maybe I have my NVMe, and that's mounted at like /OS or something. If I have a container that's running, if this is running like image, it might expect all the data to live at like /Etsy/image. Well, I can make a directory inside of /data. I don't know how to represent that. At like /data/image, and I can mount that inside. And so in reality, like when the software in here is talking to this path, it's really talking to this path on the host operating system, which is on these drives. And so as long as I don't ever like wipe or delete anything in /data, I can completely reinstall my operating system and do whatever I want over here. And once I get the new operating system up and running, I can just, say Docker compose up and all of this stuff will come back up online because I didn't touch anything in /data, and this is all just expecting it to live there. And then you can do stuff like have like a /data/plex /data/nextcloud, and all of your stuff can just live in a nice organized file however you want. And if all the software, Nextcloud is definitely one of those that's like super opinionated about where stuff needs to live. You can just tell it, no, you're all going to live here, and I'll mount you wherever you need to be inside the container. Right, so that's what I was trying to get at here with like all your configs for your various services can just live in one place, and then it makes backups really easy because you can just say back up my entire /data drive, right, and you don't have to worry about anything else. Yeah, so like if you're doing updates, definitely make sure your host operating system stays up to date. Use your package manager for that. And with the containers, you can just say Docker compose up, force recreate, and it'll rebuild everything. Okay, backups. So this is a really important thing. I wish I paid way more attention to this. There's a super common rule called the 3-2-1 backup strategy. So the rule is 3 copies of your data on 2 different media where one of those media is an offset copy. As an example, maybe you have a copy on your laptop, a copy on your Homelab, and a copy in the cloud. You'd follow the 3-2-1 rule. If you have a copy on your laptop and a copy on your Homelab, and that's it, you're not following the 3-2-1 rule. You could have laptop, Homelab, your buddy's Homelab who lives in a different state. That could work. But the reason why RAID isn't sufficient is because RAID protects you from uncorrelated failures. So if like one hard drive just dies because of a manufacturing defect, RAID protects you. If you spill water on your Homelab, both your hard drives are going to be hosed. right? If there's a fire in your house, both your hard drives are hosed. Somebody steals your Homelab, both hard drives are hosed. If there's like a power outage and there's a power surge or whatever, and it fries your hard drives, you're hosed. If you plug the same looking barrel connector into the wrong ports and put 19 volts to your hard drives, both hard drives are fried. If you take the cables from your fully modular power supplies, which look identical, have the identical shapes, and have the identical looking pinouts, but really have different pinouts, both your hard drives are fried. This is my graveyard of dead hard drives. There's like 20-ish terabytes there, just fried. So RAID did not protect me from any of this. My offsite backups did. And the other thing is you can't just like set up offsite backups and then be like, I'm good. That's what I did. And unbeknownst to me, like a month and a half before I did this damage, my backup stopped happening. Right. So now I have a reminder every week to check my backups and make sure that they're still happening to the cloud and that there's not like some billing issue or the software got broken after an update or whatever. Okay, so remote access. So let's say you get a bunch of stuff running on your Homelab. You can access it from within your home network. We can access the Home Assistant on that server from in here. Like if you go in that other room there, the computer can pull it up, no problem. But I think just Hardik and Doug can access this Home Assistant from outside. And they're doing that with VPN. Another way you can do it is with port forwarding. So, okay, how do ports work on the internet? Basically, I don't know if you're aware of this, but anyone can try and talk to your home router at any point in time, and it will just immediately reject it, unless that communication originated from your house. So if you're at your house and you turn on your TV and you go to Netflix, your TV initiates a connection with Netflix. As that connection passes through your router remembers, okay, the TV is talking to Netflix. So then when Netflix responds, the data coming back hits the router, and the router goes, okay, that's Netflix. I know the TV was talking to it, so I'm going to send the data to the TV, and it allows the connection to happen. If some random server in China just like hits your router with some data, your router just drops it on the floor and says, not this time, China. And so that whole thing is called, part of it's like network address translation, and part of it's firewall rules. So what you can do is you can actually break that behavior, and you can say, hey, when someone from the outside tries to talk to you on this specific port, just let it through and send it to my Homelab. And so now all the traffic to that particular ports are like, just like different doors to your house, like different ways that the outside world can try and talk to you. You can say everything to this port, go to my Homelab, pass all the traffic through. That basically makes your Homelab a public web server, which maybe you want that, right? So I know like Avia, you can hit Avia's Homelab, like you can go to certain websites, I forget their domain name, and you just pops up. You don't have to do anything fancy. So it's total access, which is really cool. But if you do that, you want to make sure whatever services you're hosting on that port have proper authentication, they have encryption, they're secure, make sure you know what you're doing in terms of security and stuff. And make sure that if someone like repeatedly tries to brute force your password, that you have something in there that like shuts them out and stuff. You don't want to have to deal with any of that, but you still want to be able to access your stuff when you're out and about. You can use what's called a VPN. So the idea is you open one port for one piece of software, and that's the VPN, rather than one port for every service. And that VPN, like WireGuard or OpenVPN, is like super secure, it's really locked down, does one job, and you can connect into it from your phone or whatever. And once you connect into the VPN, it's like the device you're connecting from is on that network. So Hardik and Doug both have WireGuard on their phones. They can go out, click a button in WireGuard, and their phones connect in here to the makerspace. And it's as if their phones are in the makerspace network. All of their traffic from their phones routes through here now. So even if they visit Reddit, they're going to be using their cellular signal to talk to the VPN here, and then the request to Reddit starts at the Homelab here and goes out to Reddit, comes back, and then goes to their phone. But it also means they can talk to things like Home Assistant and whatever else from their phone without exposing Home Assistant to the outside world. Hopefully some of that made sense. This is sort of like opening a back door that only you have the key to. And it is more secure than just opening up the port willy-nilly. Basically, revisit the slide on your own time after Xavier's DNS talk. But there's a way that you can basically buy a domain. So I own herbein.house. And Herbein.house does different things depending on if you're outside or inside my house. And that's split DNS. And it's really cool. You can do lots of cool things. But wait till you know more about DNS and then come back to that slide. So let's say you want to do port forwarding. And you want to open up your services to the outside world, or you just want to lock down things inside your house because you're paranoid about people coming over, or maybe you live with your parents, you don't want your parents to be able to access your stuff. What you can do to centralize all of your encryption and authentication and everything into one place, so you can use what's called a reverse proxy. So the idea here is you have your Homelab, it's running all these services like Image and Nextcloud and Plex, and each one of them may have its own authentication and encryption or whatever. It's a real pain in the ass to set that up on each one of these. And maybe some of them don't, Maybe, actually each of these do, but maybe there's a fourth service that you have that doesn't have good authentication. So you can't set it up. So you put a reverse proxy in front, and now all the traffic from your computer and your phone goes to the reverse proxy first, and then it routes it to the correct service. So like at my house, if I go to image.herbein.house, like this is the thing that the reverse proxy uses to know where to send it to. If I put plex.herbein.house, it'll send it to Plex. And then you can put all of your encryption, all of your authentication in the reverse proxy. You put it in one place and it applies to all your services. So like at my house, my reverse proxy knows how to talk to what Let's Encrypt, so it can get an SSL cert, get an encryption certificate. So if you go to HTTPS, any of the services that Herbein.house, you get the little lock icon, and it'll all be encrypted. I haven't set this up yet, but what you could set up is single sign-on. So the first, when you try and access one of the services, the first thing you'd be greeted with is a thing like this. Then you would log in, and then it would grant you access to the service. Something else you can do for security is you can install something like fail to ban, which if you've opened up your Homelab to the public internet, it'll watch for authentication attempts, and if it sees a bunch of attempts from the same IP address or to the same user, it's sort of blocking that for you. You can, Xavier added this, so talk to him if you want more info, but you can add local firewall rules with tools like uncomplicated firewall and IP tables, where you can basically say like, only these IP addresses on the local network should be allowed to talk to my Homelab. So that way you can set it up so that like only your phone and your laptop can talk to it and nobody else's thing can. Right? Maybe you have some like security cameras from China and you don't want those talking to your Homelab. You can block those out using this. It's not as good as VLANs, but better than nothing. So yeah, if you want to learn more, r/self-hosted is a really good resource. I linked this earlier, the awesome self-hosted. I also linked earlier the data hoarders. Check all of those out. Okay, this is the fun part. Now we move to show and tell. So this is slides made by various people within the makerspace who have Homelabs who wanted to share their setups. And the idea here is just to show you like the wide range of use cases and like what the wide range of what a Homelab can be. Okay? It's not just necessarily one thing. All right, Thomas.
That's mine. Yeah. Yeah, I have a huge rack mountable Dell server. I bought it refurbished off Amazon for a pretty good price. It was like $400. And so it's kind of a beast of a machine. And yeah, those are the specs up top. I got RAID 5 set up. I've only had it for like a month, so there's a lot of stuff still to be done to it. But I also have a smart switch, so I can set up VLANs and quality of service and all kinds of fun stuff, and manage it from like a web UI. I have an Edge Router 4. I'm thinking about getting another Edge Router 4 from my boss, and setting up VRRP just to like practice. It's virtual router redundancy, just to kind of practice with that. And I have a Aero mesh system, so it's like Wi-Fi 6. I also have an Aruba AP that I I didn't steal it from one of the schools I work at, but they replaced their Arubas with Meraki's. So I took one of them, and it's.
That sounds like that.
Well, they were gonna be trashed anyway, so and they're actually pretty nice.
Recycle.
Enterprise level access points, and the reason I have that is you can't set up. You can only set up like one SSID on the Eero mesh system because they're just designed to be like very simple plug and play Wi-Fi systems. So I'm gonna set that one Aruba up so all my IoT devices can be on it and on like a separate VLAN. And for software, I have Proxmox set up on the server. It's a Type 1 hypervisor, so it's essentially just like the OS that's running on the bare metal server. And then I have a Rocky Linux VM I set up like a couple days ago. I migrated it from a laptop because my Homelab started off as just like a laptop, right? And so that was a fun project. It's getting migrated over. It has a Pi-hole DNS set up. I use Docker Compose to containerize it. So that's pretty cool because if you set one of those up and you have something like Peacock or Paramount Plus and you're paying for like the version where you still get ads, you can actually block the ads using Pi-hole DNS because you just set up your DHCP options so that all of your local clients are using that DNS server. So have a WireGuard VPN. I have a Kali Linux VM for practicing like ethical hacking stuff. So I was using that for like practicing like man-in-the-middle attacks with like EtherCap, stuff like that. And yeah, that's at the bottom. Those are just some projects that I want to do going forward.
So talk to Thomas if you're going to do a Windows server.
Do what?
I said
Oh.
talk to Thomas if you're going to do a Windows
Yeah,
server.
well, talk to me in like a year.
Why would you use Windows Server?
So I work with a lot of Windows servers for my job, and they're all like the standard installations. So there's like a really resource intensive GUI that takes up a lot of server resources, and I want to try to learn the core, Windows Server core, which is just strictly command line, just because it's more lightweight and it's just a good skill to have, you know,
Nice.
for like professional reasons.
So maybe to double click on the VLAN bit. So VLAN, like right now, if you type in the password to the Wi-Fi here, the makerspace, once you connect in, every device can see every other device. There's nothing like segmenting anything. What a VLAN does is it, in the actual hardware, has ways to segment where you can say like, okay, like if you come to my house and you go to those herbs-guest, you get put on VLAN 5 or whatever. If you go to these herbs-IoT, you go on an entirely different VLAN. If you go to these herbs, you're on a third VLAN. And so the devices in different VLANs can't see each other. And then my like security cameras are in an entirely different VLAN because I got them from China and they constantly try and phone home, and like I don't want them to get malware and like, you know, see all my stuff. So they're on an entirely different VLAN. So everything's on a different VLAN, so that like only my personal devices can talk to my Homelab, my guests' devices can't, the IoT devices can't, the security cameras can't. And then like if someone comes in and tries to hack my stuff, please don't try that. But if someone were to, you know, in theory, they wouldn't be able to get to anything, and they wouldn't be able to like compromise my IoT devices or anything. Okay, Dane.
Oh. Hi. So I have a bit of a kind of a duct tape together setup there. So I just use a Raspberry Pi for 8 GB with 8 gigs of RAM and a 5 terabyte external hard drive to store stuff. On that, I'm running Diet Pi, which is like this super stripped down version of Raspbian. There's no GUI by default, you'd have to install one in it. But it's mainly meant for single board computers, and it's so stripped down. It doesn't even come with open SSH, which is kind of your traditional secure shell solution. This one uses Dropbear for file sharing and other things. The main stuff I'm running on that is Pi-hole, which does ad blocking and also acts as a local DNS resolver for me. So when I type in a URL for one of my services, it interprets that and knows what IP address to send that to. I use Nginx Proxy Manager as my reverse proxy manager. So that takes the URL passed by the Pi-hole and then points that to a specific Docker container running on the Pi. I'm only running 2 programs on it at the moment. Vault Warden as a password manager, which I've been trying to get working with my own self-signed certificates, which has worked on my laptop and my desktop, but not on my phone as of yet, so trying to work that out. And Jellyfin, which is a media server that I mainly rip Blu-rays to and use it for streaming in my apartment. I have all of them running on Docker, and I use kind of an internal Docker network to interface everything together. Once I get kind of the Vault Warden working on my phone, I plan to eventually do a Nextcloud instance and then maybe a VPN, host a VPN so I can remotely connect to it from outside the apartment. As it stands, I only want to connect to it in my local access network.
Awesome. Logan.
So, software-wise, this is a bastardized version of what we want to call a server. This was originally my just PC that I built in 2019, and like 2021, I started using it as a server. Still bare bones. I'm still upgrading it, but everyone's got like things saying Docker containers. No, I just have a folder system that I put everything in. I have Plex manage it to organize it. Nothing really special going on. Based on my movies, TV shows, books, audiobooks. That's about it. I use Homelab VPN, someone recommended it, and I like it. Have that going through. I tried to set up a online manager to communicate remotely to automatically grab the media files. I'll keep that vague. Didn't follow that, but that's about it. I'm slowly upgrading. Hopefully, I'm going to get a full dedicated server that will basically be what my PC was in 2019, but with the necessary components upgraded, and have my personal PC again. That's about it.
Sweet. Avia is not here to present their Homelab, but that's their server. They have a bunch of RAM, a bunch of storage actually. So this is parity. This is like RAID 1, where it copies it. Their recommendation was to buy all the server parts off eBay. They saved a bunch of money doing that. So here's an example. It's like half the price to get the refurbished hard drive. And like you might be like, refurbished hard drive. But if you have stuff in RAID, hopefully a hard drive failing isn't as big a deal. And if you can you can buy twice as many hard drives. Yeah. Why not? So they run a bunch of things here: audio bookshelf, Jellyfin, Minecraft server management, I don't know, Nextcloud, WordPress, and I think most of these are accessible from the public web. So they're doing port forwarding for that without a VPN. And then I think they're doing all of this through TrueNAS, and they're able to run stuff through like TrueCharts. So this was one of those like batteries included operating systems that's like a little bit easier to install stuff through. But it's still Linux rather than like a lockdown Synology or QNAP. Xavier also couldn't be here, but that's his server. He has the split SSD hard drive thing, and then backs up to an external hard drive. So these would be media 1, these would be media 2, and hopefully he copies to a third media that's like in the cloud for his backups. He's doing stuff with OpenSSH to remote in. He also runs a local DNS, but not through Pi-hole. He uses unbound and bind. I'm sure you'll hear more about that in this talk. Daniel talked about NFS, and I forgot to talk about that. But that's
basically like a way that you can just expose the files on your home lab to all the other computers on the network. They can like mount it like it's a shared drive on the computer. And NFS plays well with other Linux machines. I think you want to use Samba if you want to share with Windows or Mac. This is their reverse proxy. They use monitoring, and they have a Porsche on top. Okay, so mine started as just my laptop in undergrad. Then it became my gaming rig in grad school, and I was able to do basically what Logan's doing with various media and just downloading stuff and having Plex serve it up. And then at some point I got bored at work one day, and I was like, I'm gonna build myself a real server. And so I bought this little guy. It's a little mini PC and a QNAP USB drive enclosure, and they all just like sort of fit on a shelf underneath my TV. And there's my modem for my ISP and my routers in there somewhere. So it was all just sort of like in one place, which was nice. And that started as just like Ubuntu with some containerized services. At some point, I started running Proxmox and put a Ubuntu VM for my services, and I virtualized pfSense, which is an operating system to be your router. So the idea is like, wherever my router is, or there's my modem. The idea is the cable would go from the modem to a port that I installed that hung out the front, and then the back end of it would be connected to the network. So all the internet traffic would flow through this machine, but it would go through that VM, and pfSense would do all of the stuff. So you can do things like quality of service and traffic shaping. Like if a bunch of people are trying to stream video, you can deprioritize video streaming and prioritize gaming or whatever. That was cool, but I would never do it ever again, because putting your home lab on the critical path to your internet access is a terrible idea. It is a horrendous idea. Anytime I had to update anything on that machine, the internet was down, my wife was pissed, I was pissed, and then when you break shit, you don't have internet. It's a terrible idea, don't do this. So this is what I have now. So this is in my laundry room. The house came with like a little media cabinet. So that's the router from AT&T, and the cable goes from that into the firewall. So that's a little dedicated appliance I bought. It's like $400. But that's what I use instead of pfSense now. And it's like totally fanless. It comes with a mobile app, it's super great. You can set up your VLANs and your quality of service, and anytime someone joins my network, I immediately see on my phone, and I can put them in a different category, which limits their access. Super great, I love it. Then connected to that is this PoE switch and this switch. So PoE stands for Power over Ethernet. You can actually push power over Ethernet cables. I think you can do up to like 20 watts per Ethernet cable. So 4 of these ports have power going over them. 2 of them go to wireless access points that are in my ceiling, and then 2 of them go to the security cameras. So like I have that exact same Amcrest camera, and it's all just powered over the switch. And it's a managed switch, so it can do VLANs, this can do VLANs, this can do VLANs. I have an Internet of Things rack, so all of these plug into here, and the ports are configured to go to the Internet of Things VLAN. That's the little screen I 3D printed a case for. So that's my like keyboard, video, and mouse setup for Svalbard, which is my rack-mounted server. And then connected to the back of that is the Edge TPU. It's made by Coral, and so that's running neural networks. So all the video footage coming in from the security cameras gets passed through that, and it's looking for other people, other dogs, other bikes. Is there anything sort of interesting that we should be recording? If not, don't record. Yeah, so now it's just raw Ubuntu. I use Docker Compose for Frigate, which does that security camera stuff, image for the photos. I love paperless, so I have a little scanner. I can scan all my documents. They get sent to a shared folder that paperless is watching. It picks up the PDF and it does optical character recognition, so you can like highlight the text and copy and paste it. You can also search the text, and it automatically applies tags based off previous things. So I have like a taxes tag, a house tag, a receipts tag, stuff like that. I'm working on Home Assistant. Yeah, I have RAID through ZFS, the Coral. I back up to Backblaze using a piece of software called Restic. That's pretty great, check that out. Yeah, I do a bunch of awesome stuff with the firewall. I can also do the DNS-based ad block. I have the custom DNS entries for Herbein.house, the WireGuard, the VLANs, quality of service, and the power. Okay, I think that's it. Awesome. Thanks everyone for your contributions to the talk. And any questions?
Yeah.